My name is Royal Sequeira, and I'm here with Chris and Aslesha. We work as machine learning engineers at Georgian. And a little bit about Georgian. Georgian is a growth equity investment firm based in Toronto. And therefore, we are answerable to SEC and so on. So we have a standard disclaimer that we have to go through. So just bear with me. This presentation is for discussion and informational purposes only. Nothing presented today should be construed as investment, legal, tax, or regulatory advice by Georgian or any of its affiliates. The statements and opinions of the presenters don't necessarily reflect the views of Georgian. Any discussion of portfolio companies or customers is for illustration purposes only and may not be reflective of Georgian's investment strategy or the performance of any Georgian portfolio company or fund. All right, with that done, let's get started. It's going to be an interactive session. So if you can go to this link, and so you would need access to OpenAI API keys. So click on the sheet and fill your emails. That would be great. And it has to be Gmail links, right? Yeah.
Yeah, if you already have one, it's okay. You don't have to give your email, but if you want one, then you can put your Gmail there.
Oh, you provided one?
Yes, yeah.
For the duration of this session.
Free forever?
For now.
For now.
Oh, yeah.
Yeah, for how long?
Do you all have Gmails? The reason it is Gmail is because we have to whitelist certain domains for it to be accessible. And then I think if you had already registered with, for the workshop, then your domain should be okay, but just to be safe, use Gmail.
Yeah, can you leave the other repo? Okay.
Yes, yeah.
You have access to.
And then, just like I said, fill it in the sheets so that Aslesha can copy over the emails to provide access.
So the sheet is at the bottom. If you scroll down the README, you see a Google Sheet icon. Yeah.
Oh, let me.
How can I find your link?
Maybe I'll do what Prashant did. So, Aslesha, how do you? Yeah, you'll have to just type this, I guess. Yeah.
Maybe you can zoom in on these
So you
slides.
can leave it there.
Is that good?
Yeah.
You will also have time later, so. We'll also have time later when Chris starts, so I think we're done.
Yeah. If you are done getting the link, I'll just go ahead and we can start with the presentation. Is this good? Do you all have the access to the link and the Google Sheets?
At the bottom.
At the bottom. This is to get OpenAI API key. Yeah, you can use your own, of course. Yeah. Yeah. This is only if you don't have access, I guess. Yeah. All right. So I just want to do a quick refresher on some of the concepts, and we can go through this quickly or slowly, I guess. This is probably a known statement, but we are in the era of large language models. There's an explosion of LLMs. Every other week you see new LLMs or better versions of LLMs appear or launched. And then it makes it very difficult in terms of going about experimentation and productionalization. So if you have a prompt that was working for GPT 3.5, and then now, a few months later, you have GPT 4.0, how do you go about changing these prompts, right? And historically, we have had prompt optimization, which is, manual prompt engineering. And then, I'm sure most of you might have heard of this or known about this, where last year there were a few guidelines as to how to write a good prompt. And then we would see things like good prompt engineers make 300K a year or something like that, right? So it was very common, like write clear instructions, be concise, do not say what to do, but rather say what to do to the LLM. So it was very, doing prompt engineering became more like writing English instructions in some ways. But I think, nevertheless, some of the techniques we learned from prompt engineering, even though it was manual, are still applicable, and you'll see later when Chris and Aslesha present this. So some of the things that we saw were like zero-shot prompting. That is, you don't give any examples or demonstrations to the large language model. You just ask it to do a task. So for example, in this case, you say, classify the text into neutral, negative, or positive. And then the text is, I think the vacation is okay. So there is no demonstrations, no examples. It's just zero shot. You can also have a few shot prompting. In this case, you provide the LLM with a few examples, like this is awesome is a negative sentiment statement. This is bad. I think it's supposed to be negative. Anyway, so the labels are messed up. But then you provide the sentence and then its corresponding labels. And then something that was also very interesting and is still so relevant today is chain of thought prompting or reasoning, right? So what you do is you have a few demonstrations or examples, and you make the LLM understand slowly why you arrived at such a reasoning. For example, if we see this figure A, we have few shot prompting where there is a question and then there is an answer, and you have a new question or a prediction, and then the answer is not really correct. This is some arithmetic question. But with few shot chain of thought reasoning, you have a question. Roger has 5 tennis balls. He buys 2 more cans of tennis balls, and so on. And then you have a demonstration. Like Roger started with 5 balls, 2 cans of 3 tennis balls, each is 6 tennis balls, and so on. It's as though you're explaining to a kid, right? And then now when you apply this chain of thought reasoning, and then you give a few demonstrations, such demonstrations to the large language model, it tends to perform well. And in some cases, it tends to perform very well. But then some of these demonstrations may not always be available. Such examples might be harder to craft. So we also saw something called zero-shot chain of thought, where if you do not have demonstrations, but even adding a prompt like let's think step by step was very helpful, and it gave significant improvement in model's performance. So that's but a bit of the review, right? So we had zero-shot prompting, few-shot prompting, chain of thought prompting, and there have been a few other toolkits like React and others. But this is sort of the state of affairs until recently, I guess, where we were doing just different kinds of prompt engineering. Are there any questions so far about prompt engineering? Okay, with that, I'll hand it over to Chris to talk about DSPy.
Thank you, Royal. So today we'll be spending some time to talk about one of the more interesting and upcoming frameworks out in the ecosystem right now, and that is DSPy. How many of you have heard of it? Cool, we see some hands, and hope by the end of this, more of you will know more about it. So before we for this point of the presentation, it'll be fairly interactive. So what you can do is you can go on to the notebook that we have prepared, and we can kind of go along it together as we learn more about concepts and how to use DSPy for your application. Do I need to refresh this? Yeah. Okay, so I'm going to refresh this, and I believe we'll see. All right, there we go. So yeah, if you were to go to the link right now at the bottom of the repo, and if you click on, so if you go to the repo, and if you were to go to the Colab link, you will now see a share key for the OpenAI API key, if you need one. All right, and for this presentation, all you got to do is go to the left bar of Colab, and you can enter it in here as if it were an environment variable, and from there, it gets picked up by this notebook. So I think for some folks, you cannot import DSPy. There is an installation issue here. What you can do is you can just delete the import statement and move it to the bottom, where we have the quick start over here. That should work. In the age of LLMs, we have a new paradigm that has been coming up, right? With LLMs, we're able to build software applications on top of them, and nowadays we've been seeing this terminology appearing more and more, where we call them language programs. In other words, they are applications or programs that utilize large language models under the hood, and that involves some aspects or some degree of configuring the language models using natural language. Amongst the applications that have been coming up nowadays, we see two kind of large patterns to the architecture. On the left, you can see something that the LLM is central to the application. You can think of this as like the traditional applications that we've seen thus far, like ChatGPT's chat interface or RAG system. In those cases, it is like an LLM core application where you have an LLM in the middle, and then you build out functionalities before and after, kind of like a chain, right? If you think of LangChain and Llama Index, for example. And on the right-hand side, we have like a different way or different architecture in making such programs, where the focus is on the code itself, where you have multiple components or multiple code or software components, each of which are powered by LLMs. And these components can interact with one another via a meta LLM, such as like AutoGPT, or just using regular Python code to instruct and guide the application logic. So I just want to point out that there are kind of these two paradigms that are appearing in the applications that we're seeing nowadays. And when we talk about DSPy, it's kind of focusing a bit more on the latter on the right-hand side, where it allows for more declarative and agentic applications to form. All right? So now, when we look at prompt engineering frameworks, I'm sure many of you have heard of LangChain, you have heard of Llama Index, and now we are talking about DSPy today. Well, there are so many ways to do things, but what do they do under the hood? Fundamentally, all they do is that they take your user input and construct a prompt that goes into the LLM, because at the end of the day, an LLM is a text transformation system. You can think of it that way, right? Text in and text out. So using that lens, we'll try to peel and understand what happens under the hood for such applications. So I think because we're having a bit of issues with the notebook, I'll just go through the slides, but I think you should still be able to follow along. If not, please raise your hand and we'll chat more about it. So on the left here is what is an example of a minimal program that you can run with DSPy. You don't have to understand the details for now. That's not so important. The idea is that you configure a GPT model as your language model. You have some kind of unfamiliar concepts for the time being. And the point is that once you run it through, once you create this object called a predictor, and then once you pass in a question for it, at the end you get an answer. In this case, we're saying that we want it to answer a basic question about, given a question, return me an answer that's fairly concise, right? And here we get an answer called American, for example. What happens under the hood is what you see on the right-hand side. That is the result of the prompt that was generated by DSPy and fed into the LLM. And so what we can see, looking at this very minimal example, is that it takes the docstring of this object, puts it at the top of the prompt. The question and answer, which are fields, are then formatted in such a way as we see on the right-hand side, and the description this optional description that we provide is also parsed on the right-hand side over here. And lastly, once we call the predictor object and we pass in a question, it goes over here, and on the right-hand side is the completion by the agent, by the language model itself, which the framework then extracts out and fits in the answer attribute. So that kind of just, that gives you a sense of what's going on. This syntax is a bit unfamiliar, but at the end of the day, it's doing nothing more than just parsing things in a way and stuff. All good so far? Yeah, cool. So we looked at this object called signature and how parts of the signature goes into the prompt. We also have this thing that we haven't looked at before, which is a module, right? Predict is one example of a module in DSPy, and it represents the simplest form of a module. And it really just is creating basic templating and formatting, as we see here. And we will explore more interesting modules as we go on. Okay, here's an example of the exact same code, but with a different module, where we use a chain of thought module. So Royal previously mentioned how there are different prompt engineering techniques, and one of them is chain of thought. And we can see how by just keeping everything the same and swapping out just one module, what happens under the hood. First of all, your answer is different. It's actually British, and that's actually the right answer for this particular question, not American. And so what happens under the hood is that your prompt largely remains the same, except it kind of adds in this reasoning piece, right? And that reasoning piece is the part that we saw previously. Let's think step by step, so on and so forth. And then similarly, when it comes to asking the LM the same question again, it also will complete what was this additional piece where it goes, let's think step by step in order to produce the answer, v ... and this is the part where it completes it. And finally, the framework once again extracts out the answer that we are interested in. Yeah. So we've seen two kind of things so far. We've seen the thing called signatures, and we have this thing called a module. So let's look into a signature first of all. The way I like to think about it is the what of your program, right? It represents the business logic, the intent, and that concept is front and center in your application instead of the LM. So that's kind of like the application-centric approach that we talked about previously. And as an analogy, it's kind of like a function where you can specify multiple inputs as well as multiple outputs, along with any additional descriptions that you think might help to guide the LM to the answer that you're interested in. Yep, all good. And next up, the second piece in this puzzle is the modules. We've seen two modules previously, predict and chain of thought. The framework provides a bunch of other modules. We are only listing the three examples over here, including React, which is also a popular one, where it's an agentic approach to having the LM think of what tools to use and then acting based on those tools. So the modules is the how of the program. It represents the prompting technique, as we've seen. And what it does is that it consumes a signature and acts on it, and each module has learnable parameters. And these are the parameters that we can then optimize later in a later slide, as we will show with DSPy, which makes it more declarative. Now that we have those two things, the magic is also when we can construct our own user-defined modules. What this means is that you're able to create your own modular units that work for your application. And why would you want to do that? There are a few things over here. It helps to encapsulate some of the implementation details so that it's more high level. Similarly, when you have a class, you have separations of concerns. You can test the inputs and outputs and add unit tests on top of them. And finally, when you have individual modules, you can construct arbitrarily complex programs by reusing those modules in other modules. I've said that a bit too many times, but we will see how this can be used to optimize your program. I will show an example of a module over here, and you can see how you just have to define a class that inherits from a DSPy module object, and it follows a very similar syntax inspired by PyTorch. where you define the init containing all the internal components of your user-defined module, as well as a forward statement that shows, once it receives an input, the set of steps that happens until you get the output at the end. So in this particular example, we've showed how we have, again, the chain of thought module. We have which consumes a signature. We also have this different module, which is a RAG-related piece, not so important for now, but the point is to demonstrate how you can have multiple things all coming together to form this Lego block that you can use on its own or in other modules. Yeah, so over here, we're just pointing out how that there are different, this retrieve piece here requires a retrieval model, and there are different providers available for those retrieval models, and you can also create a custom one for yourself. With that said, maybe we can run through the notebook a little bit. I do apologize for a bit of a hiccup, but maybe we'll just see it on our end, since
we also added
yeah?
the OpenAI API key just to the
directly.
notebook.
Yeah.
So sometimes OpenAI does block it, so that's why we were trying to go through the whole word route. But try it, maybe you can see if it works now.
Sorry, what?
Sorry? We added the key directly.
We added it directly over here, though we'll need to do,
So that you
yeah.
don't have to look at your emails maybe. So hopefully you should be able to follow along now.
Right. So just kind of running along the notebook to reiterate on the things that we just talked about. In the DSPy, you import the module, you define your language model. In this case, nothing too unique so far. And then you just configure the language model as we see over here. And then when we look again at the example, you can see how, one thing I do want to point out is that you don't actually see the language model anywhere in the code, right? It's kind of like hidden in the background. And that's why I kind of say that this is an application-centric architecture when it comes to prompt engineering. So when you run it, nothing fancy, you get this result object, which holds the output field of your signature. And once you run that, you can inspect what's going on by looking at the history within the language model object. And that's basically what we see over here. Yeah. And then the green piece is the part that's completed by the language model. Yes?
When you're using a more, is this just using completions, or is this using some type of attention mask, or mask fill on a prompt with a whole bunch of other context?
So I think the implementation really depends on the integration specifically, which I suspect is completions, nothing too fancy.
Okay.
But you have to look at the individual integrations implemented by each of the third-party providers on how it works.
Does that mean that there are some DSPy features that aren't able to be used with different LLM providers?
I would suspect that it's probably the common denominator, which is the completions piece,
Okay.
right? Yeah. So yeah, we've shown a quick example over here, and then at the bottom in this piece, we're just showing how you can add in chain of thought, and then previously you got a result that was American, and now you get British, along with some rationale that is also provided by the language model on why it thinks that's the answer. Once again, you can always inspect the history. And at the bottom, you just see how it adds in the piece over here. So far, so good. Any questions?
What's the bottom paragraph? Why does it repeat itself?
Yeah, that's just an implementation detail. So basically what happens is inside of this method, it prints it, and it also returns the same string. That is all. Nothing too fancy over there. Yeah. So here's an example, again, once we've shown how you can take a built-in module and make a user-defined module by wrapping it as such, right? You define the class with the module, you add in, what would be a case here? I guess it would be something like this. I take a built-in piece, I put it here, and there we go. Nothing too fancy right now. And then we just simply showed how you can make this more complicated. In our case, we can make it more complicated by adding a RAG component to it, so we can look up some questions and answers. And all you gotta do is just find the appropriate implementation.
Can you go back? I think
Uh-huh.
it's the to-do input. I don't remember. So there are a few parts in the notebook which are left out, so that you can also do it yourself, and then sort of get the hang of DSPy thing as we go through it together. So Chris might have filled it.
Yeah, I should apologize. Yeah, I should have mentioned that I'm filling in as we go. But yes.
What do you define as input field? Like, is that for us to?
Input field is just a marker within DSPy to tell it that this attribute or this field within your class, this is a Pydantic base model, by the way. It inherits from Pydantic, so if you know Pydantic, this is pretty straightforward, but it's just an additional marker to say, this is an input, and this is an output, and why you want to know that? Because if it's an output, it will extract the right string, the right completion, it will extract the right part from the completion. Yeah. So going back here, we've shown how we can just wrap a model, so a built-in module into a user-defined one, and then maybe you want to make this more complicated by having a retrieval model. So this is a built-in, this is, for example, one implementation of a vector DB, right? So in the prior piece of script, you might have like ingested some data, loaded, chunked, and put some data into a vector DB. And here, you're just pointing to that vector DB and as a retrieval model, right? And all you got to do is just reconfigure your global settings to say, hey, DSPy, I'm using this language model as well as this retrieval model. And what this extra piece here does for you is that you can now retrieve an object from it. So for example, we have this retrieve module, and by asking it a question, by feeding it a question, we can get some passages out of it, right? And what we can do with all this piece is that if you look at this generate answer here, which is a more complex example of a user-defined module, if you were to like create if you were to include the retrieval piece over here, what you can do is you can add custom Python logic in between as needed for your application. So in this case, we've seen how retrieve obtains a list of passages. Yes? Yeah, thank you. Yeah. So you take your question that is provided by the user, you feed it into your retrieval object, and this returns passages. I believe this would work. If not, you can always just change it with Python, right? So if we were to run this, you can see how now that the result that you get, first of all, the question goes in, you get a bunch of context out, and that context is then augmenting the answer that you get out from the language model, right? And at the end, you get British. Again, this object can be anything you want. You don't have to include context here. I'm just including it in so that it's easy to debug. Yeah, I'll pause there for now. This is kind of like the basics of how to use this framework. If you're good, we can talk about more interesting things on why DSPy is probably getting more popularity. Yeah. All good? In that case, I'll hand it over to my colleague, Aslesha, and she can talk to you through some of the more advanced stuff.
Okay, thank you, Chris. Does anyone have any questions so far? Are you able to follow along? We have left some to-dos in there so that you can fill it out. Okay, cool. Yeah, so there are some other advanced concepts within DSPy. For this tutorial, we are only going to talk about optimizers, the structure output, and the assertion and the cessation piece. So let's start with the optimizer. I think I'll go back and forth between the slides and the notebook so that we can go through each of them at a time. So for the optimizers, DSPy provides some of the optimizers like Bootstrap, Few-Shot, and things like that, which can help you with the optimization of the prompt as well as the LLM weights. For the weights part of the optimization, it can only happen if you have like local smaller LLMs. But for the prompt optimization, they have a few of these modules that you can use out of the box. Yeah, and what it looks like is, like, for example, for the Bootstrap Few-Shot, you'll be providing it with like a bunch of examples, and it can also generate the examples on its own, and it'll do some optimization behind the hood with the compiling and stuff like that, and then it'll pass in the whole prompt at the end. Okay, let's see how that looks like. Okay, so before we start with the optimizer, one thing I want to point out is DSPy has its own object for examples or the data set. And so this is, if you have any questions, you can ask me, but I'm just loading in the hotpot QA here. And what it does is it defines this training and the, like the dev set, which has the input and also the answers that it can use during its optimization processes. We'll see what it looks like once it's done loading, which might take a bit. Yeah.
When you say the weights, what are you referring to? What weight? The model weights?
Yes. But yeah, behind the hood, I don't exactly know how it works, but what they say is that you can do it for some of the smaller LLMs that you have hosted locally. So there is one of the modules called Bootstrap Fine-Tune. So if you are to use this, then you can do model fine-tuning with it.
So this is like you have a prompt and you have an answer that you want it to do, and then you're doing like low-rank adaptation to fine-tune it to a particular output that you want.
Yes. Yeah. For the exact kind of algorithm, I'm not sure what it uses behind the hood, but yeah. Okay, so it's still loading. While that's loading, let's maybe go through this then. So yeah, for the techniques, we have only listed a few here, but they have like 9 or 10 that's listed in their documentation page. And what the general suggestion is that if you only have like 10 examples, then Bootstrap Few-Shot is a good one to start with. And if you are also beginner and don't have like advanced knowledge on this, like that will provide you with a good performance out of the box. And what the Bootstrap Few-Shot does is it takes the examples you provide, but it also uses the LLM that you have configured to generate the examples. So it will provide the examples. It will basically increase the number of examples you provide. Yes.
So are you writing an evaluation function for that or something? So that
yes, we'll get to that afterwards. Yes.
Okay.
It does have an evaluation function out of the box that we can use. Okay, so it's downloading now. So basically, the example object looks like this. For the hotpot QA, they have the question and the answer, but for your use case, you can define your own example objects, and you can have like multiple inputs in here, and you can provide the multiple outputs as well that you'll be using later on during the evaluation. Only one thing is that when you create these examples, you have to provide what the inputs are. Like for the outputs, you don't really need to specify it here, but for the inputs, you'll have to specify what's your input here. Okay, so I'll be using this dataset training set to run the Bootstrap Few-Shot optimization here. And one other thing that we need for the Few-Shot optimization is the metric function. So basically, when you are like training your neural networks, we have this concept of like loss function minimization, right? Or metric optimization. And here you can sort of think of it the same way. So basically, you are providing your metric here, and what the Bootstrap Few-Shot does under the hood is it tries to choose the examples that gives you like the best metric that you have defined here. and it will use those examples as an input to the LLM later on. Okay. Yeah, so going back to the evaluation piece, we can just take the evaluate module from the DSPy, and then you can pass in your whole set, like the dev set here, and then we will be using the same metric. We can define a new metric here, or you can also use the same metric you used during your bootstrap. Yes.
Summarize the metrics in the previous and this one. What's the difference?
So here, during the bootstrap view shot, we are using. So you mean like how it's used under the hood?
What is answer exact match? What is answer passage match?
Oh, right. Okay. So the exact match. So I think this one is like taking the exact output of our signature that we have.
Open sequence is your
Yeah, it's like equal. Basically, the prediction is equal to your answer.
So it's kind of like text equals text versus passage match is text in text.
But like equal is a very strict condition.
It is very strict, right?
Okay.
So the point
Yeah.
is like here is where you can define your user. It's completely user defined based on your task and use case. You can define something that mimics more closely with your business metrics.
Yeah. So yeah, this one is very customizable and flexible. One other thing that you can also do is like have LLM as a judge here. So you can define your another LLM and then put that prediction and the and the example that we defined here, like your ground truth, into that LLM, and then ask it to predict whether that looks like the right answer or not. Yeah.
Sorry, I didn't actually get the role of that bootstrap view shot.
Mhm.
What was the goal of this piece of code?
Yes.
Actually, what you are trying to optimize?
So basically here, the bootstrap view shot is optimizing for the prompt itself. So there are other modules that I kind of pointed out, like the bootstrap fine-tune, which modifies or optimizes the weights. But here we are just optimizing on the prompt that gets passed into the LLM.
And then the output of this optimizer would be
Um,
one prompt or one
Yeah, so
prompt template. What?
yeah, it is the prompt template. We don't, so it is handled by DSPy, so we don't get like the prompt and then we don't need to pass it in again. So when you do like optimizer.compile, and this compiled rag already has this prompt passed into it. But if you are interested, I think we can look at the inspect history. Let me see.
It's on the language
Yeah.
model.
Oh no, I see. It tried to.
Yeah, so it has like a bunch of question answer that we haven't passed anywhere in the prompt, right? But this bootstrap view shot injected it into the prompt.
So it can come up with demonstrations, like examples, the right prompt and examples, but it can also synthetically generate these.
Right, search for probably the most optimized prompt that you
Exactly.
could
Yeah.
achieve.
It goes from zero shot to few shot.
Yeah.
And I think in some ways the idea, I think like Chris mentioned, is if you were to tomorrow totally switch to a new LLM, you have the program written. You just have to switch the model rather than rewrite the whole prompt, come up with the right examples and all that. Just compile it. Sorry, are there many questions?
What if the answer is not so explicit? Sometimes the answer is not like a 1950 kind of year or whatever. It's like something that's potentially got variations in it, right? Like, is it always going to be like?
So to tackle with that, you can have some flexibility in the metric you define. So you can choose to, make your metric a bit vague, or like I said, use LLM as a judge, or So you can get creative here. In case of coming up with the question answer itself, so Bootstrap ViewShot does come up with some examples using your teacher LLM, which is the LLM you pass in. But I'm not sure if they have a module that can come up with the examples itself. Yes.
So, if I'm understanding this correctly, we've got the optimizer. Well, we've got that function there, which is sort of our loss function between what you want it to be and what we have in our training set, and then the optimizer, as in any other machine learning optimizer, will adjust the prompt or in a adjust the weights using some formula there, how does it determine how to change the prompts and what changes to make to these prompts to get the right answer?
Yeah, so here it's basically just bootstrapping. So there are also other like arguments you can pass in, like the number of examples you want to add and things like that within here. But here it's just randomly choosing, and like it takes like multiple of these sets, right? And then it evaluates on those sets and see which one is the best.
But then it's editing the original prompt, or is it just appending?
I don't think that it changes the option. We don't have option. It probably is something like you have a judge that gets like a bunch of prompt and then generate a new one, something like that.
But I'm just trying to like understand the analogy to an actual NLP or neural network optimizer, which takes the loss and then tries to adjust the weights. And in this case, the weights would be the end shot or the prompt end shot prompts that you've got. Or is it just is it an append only optimizer that tries to get the right answer by just appending to the end shot prompt?
Yes, so here we are not changing the weights. This one is only optimizing the prompt.
Yes, sorry, by that I mean like in an optimizer in a neural network, you would adjust the
Yes,
weights,
yes.
You'll have momentum and everything like that.
Yes.
In this, how are we actually changing the prompt? Are we only appending to it, or are we taking the examples that exist in there and then trying to like get them to be closer to the actual answer?
I can take a stab at this perhaps, right? I
Yeah.
think I see your question because like in deep learning you are iterating on the same instance over and over again.
Yes.
And in another case, so I think this is probably not doing that. It's probably closer to like if you take like XGBoost and you train it, right? Every training, okay, this is maybe not the best analogy, but I think what happens under the hood is that when you do bootstrap few shot, there are a number of iterations, and each iteration is independent. So it is not appending, right?
Okay.
It is taking it's bootstrapping a few examples and seeing how well does that perform against the depth set.
So it's essentially trying to do some like perplexity minimization between the context that you've got and the output that you want.
So the complexity would be the loss function.
Gotcha.
It can be any loss function, right?
Yes.
Yeah.
Sorry, let's just, yeah.
So who is generating this question and answer? Is it the LLM or is it like my question? The next question being because is it in your control when you're coding that you get this question and answer, or is it that the LLM that is OpenAI is generating this?
Yeah, so it depends on the module you use, like what kind of optimizer module you're using. For the bootstrap view shot, it takes in, so we are passing in this training set, right? So it will take like a bunch of examples from the training set itself, and it will also generate a few of them itself, like
Also,
in
the
here.
question and answer specifically is due to the signature that we have, where the fields are question and answer. If your fields are completely different, then it will be those examples as well.
And am I keeping history of also of the multiple iterations that you were describing? In the sense of, because if you're saying that I'm taking the prompt and I'm going through multiple iterations and to arrive to quote unquote the best answer, what if there was an iteration that was not provided to me but
Could be better, right?
could be better, or I might be able to just flag it or tag it as a better answer for my use case? Do I have a way to show that?
If I were to guess, I'm just speculating a bit, it would be the optimizer.
Okay.
I would guess. You have a question at the back?
No.
Good, yeah, okay.
And then there was a question here.
So, because we know for the same large language model, different tasks or different questions typically need different kind of format. So in this case, like even for the same large language model, so do you just create a bunch of different classes for different type of questions? Like for example, okay, if you want to get asked for like in a particular format, then you have this class, and if you want to embed a model, true model, they have another class. Then at the end of the day, you still end up with a bunch of all those kind of optimizers for the same language model that you have to maintain.
I see. So you're saying that you have slightly different use cases,
Yes.
right? I think this is a matter of a program structure question. You have, it's a design trade-off between having one that can do many things, but maybe they are a bit not so good at it, or having a specialized one for each different use cases. I think that's the answer. If you have one for every different use case, unfortunately, you probably would have to optimize each one of them on their own. But then there are also cases where you may have different modules that are part of each other, in which case you can just optimize the parent module. And then everything internally is recursively optimized. That's my understanding.
Can you show the trade set that you used?
Yes. So this is one of the examples from the training set. So if we were to look at like, say 10 of these, this is what it looks like.
I
Yeah.
have a comment here. I personally think that except for fine-tuning that you explained, the rest of the stuff will be done fully by LLM. I don't think we have any mathematical or statistical similarity or loss or something. That's why that probably you do bootstrap, pass it to the LLM. Bootstrap, pass it to the LLM.
Yeah.
Finally, you reach at a point that hopefully this is a good template for your.
Yeah, it's more like I think picking the right examples, like what's the most representative examples that improves the performance, and then also pick the prompt.
So then at the back end, we will be doing, say, let's say, it run 10 different question templates first and say, hey, this style typically give me the better one, and now for the next 10, try to get closer to this style. Or is it completely random at the back end?
I think bootstrapping is random.
Completely random, so there's no actual optimization done at the back end.
No,
It's
but
a discrete kind of optimization. Right? Again, Bootstrap is just one of many approaches. So if you look at the documentation, you might find one that fits more to your use case, right?
So in the interest of time, maybe
Yes.
we'll move on
Okay,
because we
we'll
have a
move
few
on.
more things to cover. But then we'll hang around and we can answer more questions.
Yeah, so in terms of evaluation, like I was talking about earlier, so you can define a metric here, and then you can pass in your like your test set, and then you can pass in your compiled RAG, which we compiled with the like Bootstrap few shot earlier, and then it will automatically evaluate. It will do the evaluation for you, give you like the accuracy metric and things like that. Okay, so let's move on to the next one, which is the structured output. So one other thing that's nice with DSPy is that you have a very good handle on how you want your output to be structured. And the way this can be done is by defining this like pydantic based model. So what you can do is you can define your output, for example, to be this base model, and you can specify your types here. You can also control like your outputs with the field to specify the range and things like that. So to run and one other thing is this structure output takes in the typed predictor and the typed, so they have a special module called typed predictor and typed chain of thought, which you can use, which I think is using like the prompt that basically tries to give you the output that satisfies this criteria. So here is the code for that. So please, copy it here or define it here, then we can run it. Predictor, right. So here, since we define our confidence to be a float, that is between 0 and 1, you can see that it adheres to that. One other way you can also control your output is with something called assertions and suggestions. And basically, this is kind of similar analogy to the Python assert, but not exactly. So what it does is, with assertion, you can define a certain criteria. Like example, your answer has to be a digit, right? And you can also provide a message here, which it will be used during your next prompting to, if your prediction doesn't match with like what you want, then it will use in the next prompt saying your answer was not an int, and then it will prompt the LLM again to give you like the answer. And if it falls within like n number of tries, which is already defined to be 3, or you can change it, then it will actually fail here. But the soft way of not failing and just proceeding, even if you don't have the right answer, is just using the suggest module here. And if you're using the type predictor, then you'll also have to use this activate assertions. Oh, sorry, if you're using the assert or suggest, you'll have to do the activate assertions, yeah.
We have also found this to be super helpful, I think, in some of the implementations we have worked with our customers.
Yeah.
This is very powerful, the assertions and suggestions.
Particularly if the LM is generating some really large output and you need to constrain it in some form, this is a very powerful mechanism.
Yeah.
I have a question about this because all of this it's all happening at the prompting level, and it's not something like outlines which actually constrains the next token generation to a set of grammatically correct tokens. So, is that correct?
That is correct.
Yes.
Okay.
Yeah, so we're almost at time. Does anyone have any questions so far?
So for the assertion, how is it different than the output parser from LangChain? Like where you just create for example, if I want a strict control attribute JSON form, I just create the pedantic class from the output parser. How is that assertion different than the one in LangChain?
In LangChain, my question is, if the output doesn't adhere to a JSON format, what happens in LangChain?
We create error.
It will just error, right?
Usually, what I would do is just create retrial if I get
Yeah.
error trial a couple times.
So that's the mechanism.
So that is doing exactly.
Built in.
Yeah, so this one, yeah, you don't have to write the code for that. This one will do it automatically, right? And it will also pass in the message you write here as a prompt to the LLM so that it knows what was the problem.
Then when I build my custom thing, I have to have a control on how many times I want it to be able to retry.
Yes.
Does it viewing?
Yeah, you can, I think, you specify yourself as well, but here it's 3 trials out of the box, yeah.
It's a default, but yeah, you can change
Yeah.
I think one abstract way of thinking about DSPy is just a framework that makes a lot of manual things that you would have done, like chain of thought, React, all these modules, and then assertions, things that you could still probably do them, but they're abstracted away in a nice framework, and you can just chain them together and then optimize the whole thing.
It is abstracted to be more composable, right? And each piece itself can be thought of as a unit in which you can apply more rigorous unit testing on it. So I feel like that's a way to kind of constrain agentic workflows to be more production ready. Yeah.
Yes. Yes.
I work with DSPy for a bit, and one thing that problem I ran into is the context window is very, 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 very limited. So is there a way to get around that by any chance? Next token in the config is only 2048.
So I think the context window depends on the model you're using under the hood. So if you are using GPT-4o or something like that, then you can specify your context window to be larger than that.
There's I'm using Gemini, right? And it's 1 million, 2 million context window.
Yes.
And it still gives it's still saying that the next token, you can't set next token more than 2048.
Oh, okay. I know what you're talking about because we were running into that yesterday. So what's wrong with that is DSPy, so there were some changes in DSPy that kind of undid the fix of the bug you were talking about. So if you are to use 2.4.9, it will work. Yeah.
Okay, let me take a photo of that.
So once again, the 2048 is a default. It might be a global default, so you can always just set it to whatever number that your provider.
With the model.
Yeah.
Okay, got it.
Yeah.
Okay, thanks.
Should we go through the limitations?
Yes. So so our quick thoughts on DSPy strengths and limitations. So we saw already, it is pretty good for agentic workflows, and it's.
Slideshow.
Oh, sure. So yeah, yeah, it is very easy to like modularize and compose between one another to like create a very powerful tool, and it's also very easy to like get started. I feel like I used DSPy on one of my projects, and when I was just using like say ChatGPT like API, then I had to do everything manually. But here I have tools that I can use, which was nice. And it also has useful assertions and suggestions. And if you're using with anything that requires output to be something other than text, this is very helpful. And DSPy optimizers are also very helpful in like if you don't want to write like manual prompt engineering, and it provides good handle on the required output format, like I have been talking about. I think that's like one of the biggest reasons I use DSPy. And the limitations are, so LLM is still inherently non-deterministic. So if you were to make some like changes in your say doc string, then it will change your output. So there are those things that's quite hard to handle, because with even a small change can make a change in your output, and you might be left wondering what happened. So be aware of that. And then there is also no chat functionality out of the box. There are limited tools and documentation compared to other more established frameworks like LangChain or Llama Index. And it also lacks support for text pre-processing. And it might be a bit of a learning curve in the beginning to understand these compilers, optimizers, and stuff like that. Yeah. So, yeah, are there any other?
Yeah, one or two questions before moving on to the.
Yeah.
Yeah, I just have one question about your experience working with the DSPy.
Mm-hmm.
Before this session, I just heard about that.
Okay.
Typically, when you work with the other framework like LangChain or Llama Index, one main problem that I have faced is they are very good with the good models, right?
Mm-hmm.
If you switch from GPT to, let's say, Llama 7 billion something, it degrades. What
Yes.
about this one? I want to see how do you
Yeah.
think about this?
Yeah, so the problem still exists here. So because like DSPy is a framework that sits on top of your large language model that helps you with like some sort of abstraction, but like your engine running under the hood is still your LLM, right? So if you are to use like more bigger and more performant model, you'll get better results. But the thing with DSPy is if you are like concerned about cost, for example, and if you wanted to switch it to like say GPT 3.5, right? Then what you can do is like build in these optimizers, which will hopefully give you like a better result, and like add in these assertions and things like that. So you can compose these different modules and build a like program that maybe compares to the newer models. Yeah.
I've got an input on that as well. You should check out Outlines, which is a GitHub project that actually builds a graph around the possible tokens that can be generated. So it essentially cuts down the search. But like this is a layer on top of the base model. Outlines fundamentally restricts the types of things that the output can be. And in some of the benchmarks, it like gets a Phi model or something coding better than models that are significantly larger than it. And it has a whole bunch of different ways that you can use it as well. So not just for learning.
Yeah.
Thank you.
Yeah, no worries. Yeah, if you don't have any other question, we'll move on to the next part of the presentation, and I'll pass it to Royal.
All right, so this wasn't written in the original abstract, I guess, for the talk, and then we changed a few things. But it's also fairly new, thanks to Prashant for flagging this to me. And I'll try my best to answer some of these questions, I guess, around this. So TextGrat is also very similar to a DSPy-like toolkit, but it has like a PyTorch-like a metaphor analogy, right? So if you see here, you have a neural network, and then you do forward pass, and then you calculate your loss, and then depending on your loss, you do backprop, and then some of these hidden layers, they get changed. So you could think similarly about TextGrat. Again, there are no actual gradients. I got confused a few times. You might have a pipeline or like a language program, like Aslesha Chris mentioned, and then you have these outputs, and then you have your final output, and then you use large language model as a critique to say, okay, I see you have, your output was not correct. Here's some ways for you to improve the prompt or your example or your initial solution. So that's the gradient bit in here. So it's just a metaphor. You just pass the feedback back to the prompt or your input to update it so that you can you can have better performance. Is that clear about what TextGrad is like?
To me, not to be honest. Is it like a soft prompting? You added like a layer or something?
It's just like, it's another framework like DSPy. It's and then you for like prompt optimization. Let's say use your example. Maybe I'll
What is natural language gradients?
It's just text feedback. Yes.
Can I explain?
Sure. Go ahead.
Sorry. It's essentially prompting a model to say, the gradient is prompting a model, hey, I got this, I want this, how can I change the prompt to make this better? And that is the gradient. So it's like a gradient through text, not a gradient through numbers.
Yeah, so I would think of this as more like a feedback, like text feedback, and then you change your input. So with gradients in, let's say, neural networks, you're working in the embedding space, you're working on the semantic space. So based on the feedback, you try to move your input or your prompt, whatever you're trying to optimize, to a semantically same direction as, or like opposite direction as your input, as your feedback. Does that make sense? So for example, here, if we look at the PyTorch abstraction, right? So you have your input, X, and then you have your model parameterized by theta, and then you have some loss, and then you optimize this parameter based on this loss. Here, this is more like textual feedback from an LLM as a critique, and then you move your text, like I think earlier when you were asking about, like, do we add this to the prompt, etc. Right? So here the prompt gets edited if you're looking at prompt optimization. As an example.
So nothing changes about the weight,
no? No weights. Yes. No.
Feedback to improve the prompt.
Exactly. It could be prompt. It could be your initial solution. I'll talk a little more about it, but there is no gradients. It's very confusing and misleading. There's nothing, no gradients here. It's just text and text feedback.
Sorry, what is the loss function here then?
So your loss function could also be, you can define your loss. It could be an LLM call saying, okay, evaluate this on a scale of 1 to 10. Or it could be, so yeah, you can define, or you have an answer and then you want to match the exact answer or paraphrase or something like that. So you can define your loss. So here, for example, in the TextGrad setting, let's say your article is your input, and that's a variable. So we want to maybe, so let's say you want to summarize this article, right? So black box LLM is just a large language model. We don't have access to these parameters, so we can't change this. But we can change the prompt, the system prompt, right? So the loss is just like rating the summary here, and you want to have maybe higher rating on the summary, and then the gradient descent here is actually trying to move towards a higher rated summary rather than a low rating. So you'll see it in the notebook, but like I said earlier, there's no.
If they put the different name, it could be easier to understand.
I think
that's the problem with that package.
The reason I think they have done it this way, and I found it a bit annoying in the beginning, is so that if you know PyTorch, it's easier to move. You can think in the PyTorch. I can see Prashant Sai here, but yeah, this is the state of the world today, I guess. So if you see, let's look at the concrete examples, right? So TextGrad for code optimization, and just a little bit of difference here with DSPy. Here you can do they call it instance optimization. So here, this is your instance, or this is your input, and you want to say, I want to change this input, or I want to update this input, right? So you have this input, like, I don't know, a lead code problem or something like that, and then you have passed this through the large language model, and the LLM gives you a gradient, which is a feedback saying, the current logic does not correctly handle this case, and then maybe you should do these things. So then you pass this feedback back to your original variable, and then you update that. So, and then you get, in the next iteration, you get a better code. Similarly, you can look at another instance optimization. Maybe you have a molecule that you begin with, and then you probably have some goal. I don't really know what this Venus score is. Maybe Chris knows. Chris has a degree in chemistry, by the way. So, and then you have some gradients, and then you keep updating this. And then this is prompt optimization is very similar to what we saw, or exactly the thing with DSPy, right? So you might begin with the prompt like this, which could be as simple as you will answer a reasoning question and something, and then you have an accuracy of 77%. But through this very simple textual gradient text grad method, you get a better prompt, and then you can get better accuracy. So let's look at one of the notebooks. So if you go back to the repository and then open TextGrad, I've used most of the original resource, but just update it a little bit. So you can run it along with me if you want. And then, so here, for example, so let's just look at some primitives, right? What does go into TextGrad? So you have a notion of variable, and variables are the data are like variables similar to like PyTorch, things that you want to keep track of, like keep track of the data and also the gradients, like the feedback maybe. So we have a sentence with a typo. So there's actually a typo here. And then you have a description, and then you say requires grad is equal to true. That is to say that this input that I have here needs to be changed. So that's my input, and then this requires, it can take feedback and it can be updated. That's my initial thing. So if we run this, I might have to do all of this from the beginning, I guess. Okay, that is okay. I can.
I think I have another link open. Maybe that one already has.
Oh, this one. Yeah. Oh, good point. Thank you. Let's see. Still takes a bit of time. No. Okay. Okay. So you see now the gradients here are nothing, like there hasn't been any feedback, right? And then we can set an engine. Engine is essentially a large language model. So we have set this to be 3.5 turbo, and then you can also generate a query using a generate method and say something like, hello, how are you? And then GPT 3.5 turbo returns you an answer. And now we introduce the notion of loss, right? So there's a system prompt. It says evaluate the correctness of this sentence. So that's our loss, right? So, and then this doesn't require gradient. I mean, it's by default false. So we can just, we can leave it as it is, or, it doesn't matter. And then it calculates the loss. So if we just maybe look at what loss looks like. Oh, sorry. So it's just a loss function. So, and then because we are operating in text space, we call it text loss. That's the method. And this is a function now, and we'll look at what it looks like later. And then, so again, going back to the PyTorch thing, right? So there's input, there's model, then there is loss, we looked at loss, and then there's also an optimization method like gradient descent or something. So here they use this textual gradient descent. Again, the purpose is to move your original text, either input or the prompt, closer to the optimal prompt. And then here in the parameters, you specify what you want to optimize, right? So essentially something that has been requires grad true. So here, X we set requires grad true. So this is the variable that needs to be updated. So we say that is the parameter. That's what I want to optimize. So now we can calculate loss. So using this loss function, right? So from here. And then we can look at loss. It says that sentence you provided does indeed contain a typo. The correct spelling should be sentence instead of sentence, and so on. And then you can send this feedback back to your original pipeline, right? So you do a backprop. Again, it feels like a feel so bad when I say backprop when there's no actual backprop, but I guess we gotta stick to this. And you see here, I haven't done an optimizer step yet, and then we can look at the gradients. So this is the feedback that X has received, that since the language model correctly identified a typo in the sentence provided. Anyway, so this is like, there's some feedback as to how you should change this input, right? And then we can look at X value before. Oh, it's not a function. You can see a sentence with a typo, it still remains the same. So now we can do this optimizer step, and then look at X value again, and then it's fixed now. So this is the instance optimization. We started with that, and then we passed the gradient, and then now it is up to date. They also talk about this zero grad, like you might have seen this in PyTorch, like where you reset your grads. This is useful when you have to run multiple iterations, and then I'll show you an example of that later. So any questions so far? Okay, so I'll move on to another example. So you have a question like this, like you have an equation, and then you wanna come up with solutions with this equation. And then here we have set backward engine as GPT-4o, which is to say you don't have to pass engine every single time. This is the critique. This is what gives you that feedback, yeah?
You need a powerful model for that, right?
You need a powerful model, yes. You need a stronger model, and then you can use another smaller model to learn these things maybe. So we are using GPT-4o here. So here we use, let's say, GPT 3.5 Turbo, right? So that was, okay, it doesn't matter. So, but for feedback, for backward engine, you need a powerful model. And then again here, this has to be true. So we want to improve our initial solution. So therefore, this is initial solution, and we want to update this. This is incorrect. And then you have, it requires gradients because this needs to be updated, and solution to the math question. And then the loss is, you will evaluate a solution to a math question. Do not attempt to solve it yourself. Do not give a solution. Only identify errors and be super concise. And then, of course, we don't want to change the system prompt. So we'll say required grads false, and then the whole role description. Similar to earlier, we have our text loss. Text loss takes system prompt as input. So here we have passed this as input. And then, like I mentioned earlier, the parameter that we are trying to update here on optimize on is solution, right? So whatever is required grad is equal to true, so we pass it here. So we run through this, and we look at the loss. So the loss is error in the discriminant calculation, and there are a bunch of these things. So let's just do loss.backward. So now it has, the loss has been propagated back, so we can see the gradients in, Gemini. We can see the gradients. So this is the feedback that it has received. And then something interesting here is, it says ensure that each step is, verification. After solving, it is beneficial to verify the solution by substituting them back. So it has given a bunch of feedback that it can use in the initial solution. So, and then we take an optimization step, and then when we look at the solution, which I think I've already run, you see these are the solutions. It gives me yesterday it would give the solution, but also would do a verification, but I guess these things are non-deterministic. So I have a do-it-yourself. We have maybe not too much time, but you can do it now or later. I don't know, have you seen this example of, I ran this through ChatGPT, a woman, Jane, who has had a son with a male doctor, finds the same son hurt in a car accident. The woman, Jane, rushes her son to the hospital. The doctor says, I can't operate this young man. He's my son. How could this be? This is the play on, I think, the gender stereotypical puzzle we have seen before. And it's so bad. It says, ChatGPT says, the doctor who says I can't operate on this young man, he's my son, is actually the boy's mother. Like they just changed the gender of this male doctor. So I have you can do this later if you want. So I have a question and an answer, and then I've left some fill this for you. So do we need gradient for the question or the answer? And then this is a system prompt optimization. So we just want you to optimize the prompt. Maybe I'll write that later. So you don't necessarily need gradients for question and answers. You need to update the prompt, and then you can go through this whole thing and then see how it performs. But yeah, you can do it yourself later. So you would think, oh, this is just like text prompt and prompt optimization. Like how good could it be? But it's actually very good for like even some of the existing problems. Even using GPT-4o, and then if you were to use TextGrad on top, it performs really well. So this is a lead code hard problem. I think with zero-shot, demonstration, you have 0.26, and then I think this is probably the state of the art, 0.31, and with TextGrad, 36%. Similarly, for like MMLU benchmarks with GPT-4o, you get really good results. And then I've just taken some screenshots from the paper, but if you were to see, there are really good examples that you can see. So yeah, 91 to 95% in MMLU college physics, for example. I'll just quickly, since we don't have too much time, so I'll just mention this with PyTorch, the PyTorch way of thinking, right? So let's say if you wanted to do multiple iterations, you want to do multiple, like for a batch, you want to do multiple iterations, collect all the loss, and then come up with the prompt. So you could do something like that, right? So you get your batch here, you reset your gradients, and then you calculate your loss, you do the backprop, and then take steps in your optimizer. But very, very interesting, and this is why I think the PyTorch way of thinking is a bit helpful. Sorry, do you mind if we take the question later? Yeah, okay, thanks. Because there's one last thing I want to mention. So LLM routing. So one thing that we have seen when we work with, I think, our customers too, it's very expensive to, it doesn't if you look at the number of, production level LLMs there are, or like systems there are, it's not really, gotten up, I think. It hasn't caught up as much, or it's pretty difficult. One of the reasons being cost. And then there are also other things like, sometimes with these OpenAI models, etc., there's like rate limiting and things like that. So this is some of the approaches we have seen is like LLM routing. So you can route between multiple models. So not sticking to one provider, one vendor might necessarily be the solution. So this is where also DSPy TextGrad comes into picture, right? You can have one language program that you can adapt to other LLMs, and then you can do some kind of routing mechanism. So it's actually very simple. This is also a very recent paper or approach. You have a query, you have a router. Think of this as a classifier that has been trained in some kind of preferential data. In this case, it was chat arena data. So users who were given response from Mixtral, response from OpenAI, and they don't know where is the response coming from, and then they just say, okay, I prefer Mixtral or I prefer GPT-4, right? So you have these preferential data, and then you train a classifier on the preferential data, and then during inference, based on your query, it could be routed to either the strong model or the weak model. So the reason where it would be useful, let's say you have messages like hello or thank you or whatever, or sometimes like summarization. Smaller models, weaker models that are cheaper could easily handle these things. Whereas GPT-4, 4o, or I don't know, Sonnet or something like that is probably a better suited option for like math related questions. So that you can let your classifier automatically learn based on your query space where should we use these LLMs. So rather than just using GPT-4o or cloud models for everything, I think you could have a more nuanced approach where you decide at the query time where what LLM you should go. So you can check this out on LLM Router. So they make it very easy to, their approach is only between two models now, which is any one weak, one strong model. And then they save about, I think, around 2 to 3 times the cost reduction for similar performance. That's it. We have about 4 or 5 minutes for questions. Are there any questions? There's also before, sorry, go ahead.
I was going to ask what you guys do, because I haven't heard anything about what you guys do yet.
We work as machine learning engineers. So at Georgian, like I mentioned maybe earlier, it's an investment firm. So we work with our portfolio companies with their product or go-to-market acceleration and so on. So we have some exposure on to what are the trends, what are the tools people are using, what are some of the pain points and so on. Yeah.
Investment like a private?
It's a growth equity, yeah.
You do investment
Yes.
on those companies?
Yes, yes.
It's like an incubator.
It's mostly at growth stage, so Series A or B later. We also have a social today with Lightning AI later this evening. So here's the QR code. If you wanna come attend, there's gonna be food and beverages and and discussions, I guess. And yeah, we can also hang out later and now and then. Yeah, feel free to come to the event. Yes. Yeah, we'll share the slide deck. I don't know how, maybe either LinkedIn or if we can get access to the emails. I don't know. We can figure out a way. But we'll share the slide deck for sure. All right, thanks for coming.
Thank you.